Epithermal deposits, or low-sulphidation epithermal deposits, which we talk about at Shovelnose and in the Spences Bridge Gold Belt, is our exploration target. That's the style of mineralization that we're looking for. There's a whole sort of spectrum of deposit types that evolve along sort of continental margins and where basins are opening up, if you will. And there's porphyry copper deposits, and then often those deposits will have fluids coming off that can be falling structures that could end up being quite distant from the porphyries that also have precious metals in them and can result in the deposition of this style of mineralization. So one way to think of it is that there's sort of a fluid or water that's coming up a crack or a structure that has gold and silver and other metals in it. It'll reach a point as it comes up to the surface where it's hot, but it can't boil because it's under such pressure when it's at depth. But as it travels upwards, at some point, it reaches a point where the pressure comes off enough and the water can boil. The other thing that can happen is that water that has the gold in it can interact with surface or groundwater, and that can result in boiling as well. But you'll get this sort of boiling event that'll happen. And along with that, you'll get silica and you'll see quartz veining, and it can happen in multiple events. So you can get this beautiful banding that you'll see in a coliform banding, we'll call it, in the quartz veins. And it's at that point, it's at that boiling point that gold and silver, if they're present, are going to drop out and they will get deposited. And that'll happen over kind of maybe 150 or 200 or 300 meter elevation where all that action happens. And then the fluids will carry on upwards even further to wherever the present day, so the surface is at the time of the deposit being formed. And though that's where some of the other metals that we'll talk about, you'll hear us talk about pathfinder elements, and that can be molybdenum or mercury or arsenic and antimony, they'll kind of carry on a bit further and get deposited a little bit further up or outside of, and that provides a bit of a halo that we can then look for and we'll talk to often when we're considering exploration. So when it comes to targeting a low sulphidation epithermal system, there's obviously the environment. You need the right age rocks, you need the right setting, the right kind of fluids. But the constraining those deposits will be dictated by structure. So there needs to be a structure that the fluids will travel up. And then you need to have the preserved boiling zone, we call it, where the boiling happened and the gold dropped out. A good example, when we talk about boiling, that we can think of, a modern example would be if you think of Yellowstone and geysers like Old Faithful, where that water is shooting up because it's boiled and it's been shot up the surface. And where that boiling is happening, if there's gold present in those fluids, a gold deposit could be forming right now. And what we see with that, I mean, it's called Old Faithful because it happens over and over and over again. But so these events, these boiling events, can happen, and they can be cyclic, and they can happen many, many times. That gives us some of that coliform banding that we talked about in the quartz veins we see. But it can also then, in some ways, telescope the deposit over time. So this could be over thousands or tens of thousands or hundreds of thousands of years, where that zone may move up and down. You can get telescoping, and you can get far more broad zone of mineralization that kind of expands on that 200 meter window of the boiling zone. So from an exploration perspective, we want to kind of target in on where was the paleo-surface that would have sort of controlled when boiling would have happened at the time of the mineralizing event. We want to look for structures and then look for, obviously, quartz veining and these pathfinder element halos, clay alteration that is associated with these systems. These are all important pieces for us to try and understand. And again, with South Zone and with FMN and Franz, but really keying in on South Zone, because it's fully preserved, we can look at what is the pathfinder element halo around the South Zone for the deposits on Shovelnose. So we know what they are across the globe for this style of mineralization, but we can get very specific sort of thresholds for those pathfinder elements that are specific to South Zone and Shovelnose, and then ideally the Spences Bridge Gold Belt. And looking at the structural setting has really been a key part of the work that we've done this summer, identifying that sort of northwestern trend that the deposits lie along as as a normal fault where the southwest side has been down faulted, and we think there really should be other faults that are subparallel to that could just as well host epithermal fluids and epithermal mineralization. And then we need to layer on understanding subsequent sort of post-mineralization movement and faulting that might have broken that up, because that certainly has happened at Shovelnose. It adds a layer of complexity, but it's also the opportunity that we see to find more deposits.